Some say black holes are not just cosmic anomalies, but the very limit of human understanding. They are the silent sentinels on the edge of science and philosophy, enigmatic, inescapable, and utterly integral to the story of our universe. For generations, black holes have beckoned from the darkness, their secrets both terrifying and intoxicating. They are graveyards for stars, tearing the fabric of space-time itself, and compelling the bravest of minds to ponder what lies beyond their grasp. In 2019, humanity achieved a milestone that would forever change our relationship with the unknown. The first ever image of a black hole, captured by the Event Horizon Telescope. It was a blurry ring, a ghostly silhouette, yet this image pierced through centuries of imagination, showing us that the cosmic monsters dreamt up by mathematics were, in fact, real. Before that moment, black holes existed only in theory, mathematical phantoms haunting the world of physics. Yet now, we could finally glimpse one shadow, and the questions that followed are transforming how we see the universe and our place within it. What exactly are black holes? How do they come to exist? And could solving their mysteries unravel the deepest secrets of the cosmos? At its core, a black hole is best described as a region of space-time where gravity is so overwhelming that nothing, not even light itself, can break free. Imagine a place where the familiar laws we live by are warped and twisted, where the fabric of reality is contorted by sheer mass. Black holes arise as a natural prediction from Albert Einstein's general theory of relativity. According to Einstein, massive objects curve the space-time around them, causing what we experience as gravity. Most objects, like planets and stars, create modest bends. But when a star, many times more massive than our Sun, collapses, it can compress matter so extremely that space-time caves in on itself, forming a black hole. The outer boundary of a black hole is known as the event horizon, the ultimate point of no return. Once crossed, escape is impossible. Not even information or radiation escapes the black embrace beyond this invisible frontier. That's why black holes are black. They swallow all light and energy, never to be seen again. Yet, paradoxically, it's this very invisibility that makes them so intriguing. We can't see black holes themselves, but their presence is betrayed by their effect on nearby matter, and the way their immense gravity warps the paths of light and the orbits of stars. These cosmic shadows, unseen but undeniable, stand as testaments to forces that can remake galaxies. Not all black holes are created equal. In fact, the cosmos provides an astonishing variety, each revealing something different about the life and death of stars and galaxies. The most well understood are the stellar mass black holes. These form when massive stars, at least several times heavier than our Sun, exhaust their nuclear fuel and catastrophically collapse under their own gravity. Typically, these black holes possess masses ranging from about 5 to a few dozen suns. They are the most common type ever observed, often revealing themselves in binary star systems where they feast on nearby companion stars, creating incandescent disks of superheated gas. Bridging the gulf between these stellar remnants and the behemoths lurking at the hearts of galaxies are the so-called intermediate mass black holes. Their masses range from hundreds to thousands of solar masses, but they are far rarer and more elusive. The processes that create these black holes remain a mystery. Do they form from the merging of several smaller black holes? Or are they the collapsed cores of unusually massive stars born in the early universe? Astronomers continue to scour the galaxy for more evidence, hoping to determine if intermediate mass black holes are a missing link in cosmic evolution, or merely rare outliers. At the far end of the spectrum are supermassive black holes, cosmic giants weighing millions, or even billions, of times more than our Sun. These monsters dwell in the centers of galaxies, including our own Milky Way, whose central black hole, Sagittarius A, tips the scales at over 4.3 million solar masses. Unlike their stellar mass cousins, the origins of supermassive black holes perplex astronomers. Some theories suggest they grow over billions of years through the merger of smaller black holes, or perhaps from the direct collapse of monstrous gas clouds shortly after the dawn of time. Regardless of their genesis, supermassive black holes play a pivotal role in galactic life, shaping the evolution of stars and the very architecture of the cosmos itself. How, then, do these cosmic traps come into existence? And, perhaps more importantly, how do we, bound by the limitations of human perception, even know they are there? The most common pathway to black hole formation is through the violent deaths of massive stars. As these stars burn through their fuel, gravity ultimately wins the battle against outward pressure. When the star can no longer resist its own immense mass, its core collapses, squeezing matter into a point of unfathomable density. For stars above a certain threshold, not even the explosive violence of a supernova can prevent this fate. A black hole is inevitable. Unlike a planet's surface, a black hole possesses no solid boundary. Its only distinguishing feature is the event horizon, the perimeter of no return. Yet black holes influence their surroundings in profound and observable ways. One telltale sign is the behavior of nearby stars. Some are seen to orbit invisible masses, tracing out ellipses dictated by gravity's invisible hand. Others are ripped apart, their remains spiraling into an accretion disk around the black hole, heating up and shining with intense X-rays detectable from Earth. Occasionally, the gravity of a black hole bends the light from background stars, creating the phenomenon known as gravitational lensing. In rare and spectacular events, the collision of two black holes produces ripples in space-time itself, gravitational waves, now observed by detectors such as LIGO and Virgo. Each of these signals tells us something monstrous and invisible is out there. Imagine for a moment what it would be like to venture toward a black hole, a journey that challenges every intuition, every expectation. As you guide your spacecraft across the cold void of space, the black hole appears first as a shadow, framed by the vivid glow of infalling matter. As you approach, the gentle tug of gravity grows into a relentless pull. Space around you is no longer simply a backdrop. It becomes treacherously curved, shaped by the immense mass ahead. Time itself begins to twist. To distant observers, your craft slows and dims, never quite reaching the event horizon. This is gravitational time dilation at its most extreme. From where you started, it looks as if you are frozen just before entry, but for you inside the ship, there's no hint of stopping. You cross the event horizon in the blink of an eye, passing through a threshold where escape becomes mathematically impossible. At this point, all paths, all futures, lead inward, deeper into the blackness. This is where spaghettification begins. The gravity at your feet is perhaps billions of times stronger than at your head. The difference is so immense that your body would be stretched into a thin, elongated filament. Every atom, every molecule is pulled apart by these tidal forces, shredded into its most fundamental components. No known material, no force we possess, could resist this cosmic stretching machine. Yet, if we could somehow continue our imaginary journey beyond this grisly fate, what would await us? At the very core, the singularity, reality as we know it, ceases. The equations of physics break down. Mass is compressed to an infinitely small point, where density falls off the charts and time itself unravels. Here, the rules crafted by Einstein and Newton refuse to cooperate, and even our wildest speculations come up short. It is a one-way journey to the ultimate unknown, an end not only of matter and energy, but perhaps of the ability to ask questions at all. This brings us to perhaps the greatest mystery of all. the singularity itself, a word that spells both the end of science and the beginning of new possibilities. In theoretical terms, the singularity marks a location where density and gravity reach infinity, a place where space and time as we know them are obliterated. At this infinitesimal point, the equations of general relativity, so brilliant at explaining the behavior of planets, galaxies, and even the immense dance of black holes, simply give up. Yet quantum mechanics, the theory governing the tiniest particles of existence, offers no clear answers either. It is here, in this forbidden zone, that our understanding frays beyond usefulness. Physicists dream of a theory of everything, a set of principles capable of uniting gravity with quantum physics and resolving the paradoxes of the singularity. Some speculate that the information sucked into a black hole doesn't vanish, but is somehow recorded on the event horizon, echoing the mysterious holographic principle. Others propose radical alternatives, from wormholes to baby universes. Whatever the case, what disappears inside a black hole may be transformed, preserved, or lost in ways we have not yet imagined. The mystery of black holes is far from solved. They remain the ultimate test of our theories and the ultimate lure for our curiosity. With every discovery, from orbiting stars revealing hidden titans to gravitational waves ringing out from cosmic collisions, we come ever closer to unlocking their secrets. Yet even as technology advances and observations sharpen, black holes continue to challenge, confound, and inspire. What we know is only the beginning. In the cold, silent gulfs of space, black holes quietly shape the fate of stars, galaxies, and perhaps the cosmos itself. By confronting their mysteries, we may one day unravel the deepest truths about space, time, and the very nature of reality. The void is not empty. It is filled with secrets, waiting for the next bold explorer to peer beyond the horizon and discover what lies within.